Hi everyone, welcome to Focal Academy. See this problem. So this is the problem on radius of curvature. So here given one equation in Cartesian coordinate system. So y means it is a function of y and x, and where a is a constant. So it is a equation in Cartesian coordinate. Now how can you find the radius of curvature for this curve at any point? Means we want the standard equation of radius of curvature at any point for this curve. So radius of curvature was represented with a symbol rho. Whenever the function is in Cartesian coordinate, the radius of curvature rho is equal to 1 plus dy by dx whole square. So for overall, whole power of 3 by 2 upon d square y by dx square. So this is the standard formula for finding radius of curvature. So whenever the function is in Cartesian coordinate system. So here we need to require to find dy by dx and d square by dx square value. Means first derivative for this function and second derivative for this function we need. Afterwards we need to substitute the two values in the equation, then we get radius of curvature. So first of all, how to find the first derivative for this function. Now see here, we are going to find the first derivative for this function, that is dy by dx, thus equal to, and y is given as dy by dx of a into log of secant of x by a. Now how can you find the derivative for this function? So when you observe carefully here, this function is chain of x, means we are going to apply the chain rule here. So let's see here how to apply. So before going to solve this problem, I want to give some standard example here. Let's see. We know that d by dx of log x equal to 1 by x. This is the standard formula. Suppose in the place of x there is a function is there, suppose g of x. So it is nothing but 1 by g of x. Here g of x is again a function of x. Now apply derivative for this, that is into g dash of x. So if you apply here derivative of x, it becomes 1, means up to constant 1 we are going to derivate like this. So this is the process of chain rule. Now we are going to apply the chain rule here for derivating this function. Here a is a constant, bring it outside. Let's consider this is completely a function of g of x. So it is nothing but 1 by secant of x by a, means log of g of x nothing but 1 by g of x. Again g of x is a function in terms of x. Now derivate this secant of x by a function. So derivative of secant of x by a is secant of x by a into tan of x by a. This is the derivative for this. So again it is a function of x, that is x by a is there. So now derivate x by a, we will get 1 by a. So this is the chain rule of derivative. Now here a cancel, secant of x by a, secant of x by a cancel. The final one is only tan of x by a. So this is the derivative of y, that is dy by dx. Now we want second derivative. So for that, derivate this function, we will get second derivative of this function, that is d square y by dx square equal to derivate this function. So derivative of tan of x by a nothing but secant square x by a. So this function is again in terms of x. So derivate this function, we will get 1 by a. So derivative of x by a is nothing but 1 by a. Now consider this is equation 1 and this is equation 2. Now substitute these two equations in radius of curvature formula. So that is here. So 1 plus we got dy by dx, that is tan of x by a. Here square is there, apply square, it becomes tan square of x by a. Overall power is 3 by 2. So upon second derivative we got secant square of x by a into 1 by a. So that's equal to 1 plus tan square of x by a overall 3 by 2 divided by, so 1 by a into secant square of x by a. Now we can simplify this furtherly. So let's hear how to simplify it. Now we need to recall trigonometry and formulas. So we know that is sin square theta plus cos square theta equal to 1, secant square theta minus tan square theta equal to 1, cosecant square theta minus cot square theta equal to 1. So in this, use this formula. So from this we get secant square theta equal to 1 plus tan square theta. So in the place of theta we have here x by a here. So it is in 1 plus tan square theta formula. So it can be written as secant square of x by a and overall power is 3 by 2 upon, so 1 by a into secant square of x by a. Here square cancel. So it becomes, so 1 by a it becomes as a into secant cube of x by a upon secant square of x by a. Observe carefully here. Denominator there is no change. Secant square of x by a. It becomes inverse. That's why it becomes a. And here square cancel. It becomes secant of x by a whole cube. So here 2 are there, 3 are there. So it remains by cancelling afterwards a into secant of x by a. So this is the standard equation of radius of curvature at any point for the given curve. And this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.